Yellowstone National Park, a name synonymous with breathtaking landscapes and abundant wildlife. But beneath this natural beauty lies a geological giant, a supervolcano capable of eruptions dwarfing anything witnessed in human history. This supervolcano is not a single cone-shaped mountain like Vesuvius or Mount Fuji. Instead, it's a massive caldera, a cauldron-like depression formed by previous eruptions hidden beneath the park's picturesque scenery. The Yellowstone caldera is a vast, mostly underground volcanic system. Its magma chamber, a reservoir of molten rock, fuels the park's famous geysers, hot springs, and mud pots. These geothermal features are a constant reminder of the immense power simmering beneath the surface. While the thought of a supervolcano might be alarming, understanding the science behind it can help separate fact from fiction. Yellowstone's volcanic history is complex and fascinating, offering valuable insights into the Earth's dynamic processes. The supervolcano's presence adds another layer of intrigue to Yellowstone's already rich tapestry of natural wonders. It's a testament to the raw power of nature and the constant reshaping of our planet. The area's unique geology attracts scientists from around the globe, eager to unlock the secrets of this geological marvel. Yellowstone's supervolcano is a subject of intense study, providing crucial data for understanding volcanic systems worldwide. The park's breathtaking vistas, from the colorful Grand Prismatic Spring to the towering geysers like Old Faithful, are all ultimately products of this underlying volcanic activity. The heat from the magma chamber drives the hydrothermal systems, creating the park's iconic features. It's a delicate balance between immense power and stunning beauty. This makes Yellowstone a living laboratory for geological studies. Yellowstone's volcanic history is marked by three colossal eruptions. These eruptions occurred approximately 2.1 million, 1.3 million, and 631,000 years ago. Each of these events ejected enormous volumes of ash and rock into the atmosphere, dramatically altering the surrounding landscape and impacting the global climate. These eruptions were thousands of times larger than the 1980 eruption of Mount St. Helens. The magnitude of these past eruptions is difficult to comprehend. They reshaped vast stretches of North America, blanketing the continent in ash and debris. The evidence of these ancient cataclysms is still visible today in the park's geological formations. The layers of tough, solidified volcanic ash tell a story of immense power and destruction. These layers provide valuable data for scientists studying the volcano's past behavior. The most recent eruption, 631,000 years ago, formed the present-day Yellowstone caldera. This event dramatically altered the landscape, creating the vast depression that now characterizes the park. The caldera's formation is a testament to the scale of the eruption. It's a stark reminder of the forces at play beneath the seemingly tranquil surface. Studying the caldera's formation provides insights into the mechanics of supervolcano eruptions. Studying these past eruptions allows scientists to better understand the volcano's behavior and potential future activity. By analyzing the geological record, researchers can piece together the timeline and magnitude of these events. This information is crucial for assessing the risks associated with Yellowstone's supervolcano. The past provides a window into the future, helping scientists predict potential eruption scenarios. One of the key indicators of volcanic activity is ground uplift and subsidence. This refers to the vertical movement of the Earth's surface caused by changes in pressure and magma movement beneath. Yellowstone experiences periods of uplift and subsidence, often cyclical in nature. These movements are carefully monitored by scientists to understand the dynamics of the magma chamber. Precise measurements help track the changes in ground elevation over time. The magma chamber beneath Yellowstone is a dynamic system. The influx of new magma and the release of gases can cause pressure changes, leading to ground deformation. The movement of molten rock and hydrothermal fluids within the system also contributes to these surface changes. Understanding these processes is essential for interpreting the observed ground movements. Sophisticated instruments, including GPS and satellite radar, are used to measure these subtle shifts. While significant uplift can be a precursor to volcanic eruptions, it doesn't always indicate an impending eruption. In Yellowstone's case, the observed uplift and subsidence are often attributed to hydrothermal activity. The movement of hot water and steam within the geothermal system can cause the ground to rise and fall. This makes it crucial to differentiate between magma-driven and hydrothermal-driven ground deformation. Scientists carefully analyze the data to determine the underlying cause of the observed changes. The interplay between magma and hydrothermal systems is complex. The two systems are interconnected, and changes in one can influence the other. This makes it challenging to isolate the specific cause of ground deformation. However, by combining multiple monitoring techniques and analyzing the data comprehensively, scientists can gain a better understanding of the processes at play. This helps them assess the potential risks associated with the observed ground movements. One common misconception about Yellowstone is that it's overdue for an eruption. This notion stems from the roughly 600,000 to 700,000 year interval between the last three major eruptions. However, volcanoes don't operate on a predictable schedule. The idea of an overdue eruption is misleading. Volcanic systems are complex and don't adhere to strict timelines. The time between eruptions can vary significantly, and there's no guarantee that Yellowstone will erupt again on any specific time frame. The current geological activity at Yellowstone doesn't indicate an imminent super-eruption. While the park experiences earthquakes, ground deformation, and changes in geothermal activity, these are normal for an active volcanic system. These phenomena are part of the natural background activity of Yellowstone. They don't necessarily signal an impending eruption. Scientists continuously monitor these activities to assess any potential changes or escalating trends. The probability of a large-scale eruption at Yellowstone in the foreseeable future is extremely low. According to the United States Geological Survey, the chances of a caldera-forming eruption within the next 1,000 years are estimated to be 1 in 730,000. This is a very small probability, comparable to the risk of being struck by a large asteroid. The USGS continuously monitors and re-evaluates these probabilities based on the latest scientific data. Scientists are constantly monitoring Yellowstone's volcanic system, using a variety of techniques to track its activity and assess potential risks. This ongoing monitoring provides valuable data for understanding the volcano's behavior and allows scientists to provide timely warnings if any significant changes occur. The data collected from these monitoring efforts helps to refine the understanding of Yellowstone's volcanic system and improve eruption forecasting. Section 5. Overdue for destruction, dispelling the myth. The idea that Yellowstone is overdue for an eruption is a misunderstanding of how volcanoes work. Volcanoes don't erupt on a predictable schedule like clockwork. Their activity is governed by complex geological processes. The intervals between eruptions can vary significantly, spanning hundreds of thousands of years. There's no scientific basis for the claim that Yellowstone is due for an eruption simply because a certain amount of time has passed. The time between major eruptions at Yellowstone has varied considerably. The intervals between the three most recent caldera-forming eruptions were not uniform. This further demonstrates the lack of a predictable eruption cycle. The timing of future eruptions, if any, cannot be accurately predicted based solely on the time elapsed since the last event. Scientists rely on monitoring data and geological evidence to assess potential risks. Geological processes are not governed by fixed schedules. The accumulation of magma, the buildup of pressure, and the triggering mechanisms for eruptions are complex and unpredictable. Many factors influence volcanic activity, including tectonic plate movements, magma supply, and the interaction between magma and surrounding rocks. These factors make it difficult to pinpoint the exact timing of future eruptions. Predicting volcanic eruptions is a challenging task. Scientists use various monitoring techniques to assess the state of a volcano and look for signs of unrest. However, accurately forecasting the timing and magnitude of an eruption remains a significant challenge. Ongoing research and improved monitoring technologies are crucial for enhancing eruption forecasting capabilities. Section 6. Keeping watch monitoring Yellowstone's volcanic activity. Scientists employ a range of sophisticated techniques to monitor Yellowstone's volcanic activity. These include seismic monitoring, ground deformation measurements, and gas emissions analysis. Seismic networks detect and locate earthquakes, which can be indicators of magma movement. GPS stations and satellite radar track ground uplift and subsidence, providing insights into pressure changes beneath the surface. Gas sensors measure the release of volcanic gases, which can signal changes in magma composition and activity. Seismic monitoring is a crucial tool for tracking earthquake activity within and around Yellowstone. The park experiences thousands of small earthquakes each year, most of which are too small to be felt. However, these microquakes can provide valuable information about the movement of magma and fluids within the volcanic system. The distribution and frequency of earthquakes can indicate areas of heightened activity. Ground deformation measurements provide another critical piece of the puzzle. GPS stations and satellite radar are used to track subtle changes in ground elevation. These measurements can reveal patterns of uplift and subsidence, which can be related to changes in magma pressure or hydrothermal activity. By analyzing the spatial and temporal patterns of ground deformation, scientists can gain insights into the processes occurring beneath the surface. Gas emissions analysis provides information about the composition and flux of volcanic gases. Changes in gas emissions can indicate changes in magma activity or the state of the hydrothermal system. Scientists collect gas samples and analyze them to identify and quantify different volcanic gases, such as carbon dioxide, sulfur dioxide, and hydrogen sulfide. These measurements can provide clues about the processes occurring deep within the volcanic system. Section 7. From tremors to cataclysm potential eruption scenarios. Several potential eruption scenarios exist for Yellowstone, ranging from relatively minor hydrothermal explosions to catastrophic caldera-forming eruptions. Hydrothermal explosions are relatively small events caused by the sudden release of steam and hot water. These explosions can create craters and eject rocks and debris, but they are significantly smaller than magmatic eruptions. While hydrothermal explosions can be localized hazards, they don't pose the same global threat as large-scale magmatic eruptions. Lava flows are another potential eruption scenario. If magma reaches the surface, it can erupt as lava flows, which can cover large areas and destroy infrastructure. However, lava flows typically move relatively slowly, allowing time for evacuation. The extent and impact of lava flows would depend on the volume and viscosity of the erupted magma. While lava flows can cause significant local damage, they are unlikely to have a global impact. A more significant eruption scenario involves the eruption of pyroclastic flows. These are fast-moving currents of hot gas and volcanic debris that can travel at hundreds of kilometers per hour. Pyroclastic flows are extremely hazardous and can cause widespread destruction. They can incinerate everything in their path and deposit thick layers of ash and debris. The extent and reach of pyroclastic flows would depend on the magnitude of the eruption. The most catastrophic scenario is a caldera-forming eruption. This type of eruption involves the ejection of enormous volumes of ash and rock into the atmosphere, leading to the collapse of the caldera. A caldera-forming eruption would have devastating regional and global consequences. The ash cloud would block sunlight, causing global cooling and disrupting agriculture. The eruption would also trigger widespread earthquakes and tsunamis. The likelihood of such an event in the foreseeable future remains extremely low. Section 8. A giant asleep, the low probability of a super-eruption. Despite the potential for catastrophic eruptions, the probability of a super-eruption at Yellowstone in the near future is extremely low. The USGS estimates the annual probability of a caldera-forming eruption at Yellowstone to be roughly 1 in 730,000. This is a very low probability, comparable to the risk of being struck by a large asteroid. The vast majority of activity at Yellowstone consists of small earthquakes, ground deformation, and geothermal changes, which are normal for an active volcanic system. The current geological conditions at Yellowstone do not suggest that a super-eruption is imminent. Scientists continuously monitor the volcano's activity and have not detected any signs that would indicate an impending caldera-forming eruption. The observed ground deformation, earthquake activity, and gas emissions are within the normal range for Yellowstone. These observations provide reassurance that a super-eruption is not on the horizon. While it is impossible to completely rule out the possibility of a future super-eruption, the likelihood of such an event in our lifetime is extremely remote. Volcanic systems are complex and unpredictable, but the current scientific understanding suggests that Yellowstone is not currently on a path towards a catastrophic eruption. The ongoing monitoring efforts provide valuable data for assessing the volcano's state and detecting any potential changes in activity. The focus should be on understanding the science and dispelling misinformation. Sensationalized media reports and unsubstantiated claims about an impending eruption can create unnecessary fear and anxiety. It is important to rely on credible sources of information, such as the USGS, and to understand the scientific basis for assessing volcanic risks. The scientific community is dedicated to monitoring Yellowstone and providing accurate and timely information about its activity. Section 9. Beauty amidst power, Yellowstone's geological wonders. Beyond the supervolcano, Yellowstone National Park is a wonderland of geological wonders. The park's geothermal features, including geysers, hot springs, mud pots, and fumaroles, are a testament to the immense heat and energy beneath the surface. These features are a constant reminder of the dynamic nature of our planet and the powerful forces that shape it. Yellowstone's geothermal landscapes are unique and captivating, drawing visitors from around the world. Old Faithful, perhaps the most famous geyser in the world, erupts regularly, shooting hot water and steam high into the air. The Grand Prismatic Spring, a vibrant pool of hot water, displays a stunning array of colors due to thermophilic bacteria. Mammoth Hot Springs, with its terraced formations of travertine, showcases the power of hydrothermal activity to sculpt the landscape. These are just a few examples of the many geological treasures that Yellowstone has to offer. The park's diverse ecosystems are also intertwined with its geological heritage. The geothermal features provide habitat for unique organisms adapted to extreme conditions. The volcanic soils support a variety of plant life, including lodgepole pine forests and meadows of wildflowers. The park's abundant wildlife, including bison, elk, wolves and grizzly bears, thrives in this complex and dynamic environment. Yellowstone is a living laboratory for scientists studying geological processes, geothermal systems, and the interplay between geology and ecology. The park provides a unique opportunity to observe and research these phenomena in a natural setting. The data collected from Yellowstone contributes to our understanding of Earth's dynamic systems and helps to inform conservation efforts. Section 10. Conclusion. A park under watchful eyes. Yellowstone National Park is a place of immense beauty and geological significance. While the presence of a supervolcano might seem alarming, the current scientific understanding suggests that the risk of a catastrophic eruption in the foreseeable future is extremely low. Scientists continuously monitor the volcano's activity, using a range of sophisticated techniques to track any changes and assess potential risks. This ongoing monitoring provides valuable data for understanding the volcano's behavior and ensuring the safety of the park and surrounding areas. The park's geothermal features, a direct result of the underlying volcanic activity, are a constant reminder of the powerful forces at play beneath the surface. These features, including geysers, hot springs, and mud pots, are a source of wonder and fascination, drawing millions of visitors each year. Yellowstone is a unique and dynamic environment, offering a glimpse into the Earth's inner workings and the complex interactions between geology, biology, and ecology. While the potential for future eruptions exists, it's important to remember that volcanoes don't follow predictable schedules. The notion of Yellowstone being overdue for an eruption is a misconception. The time between eruptions can vary significantly, and there's no scientific basis for predicting the exact timing of future events. The focus should be on understanding the science, dispelling misinformation, and appreciating the unique geological wonders that Yellowstone has to offer. Yellowstone remains a place of ongoing scientific inquiry. Researchers continue to study the volcano's behavior, refine monitoring techniques, and improve our understanding of volcanic processes. This ongoing research is essential for assessing potential risks and ensuring the long-term safety and preservation of this remarkable natural treasure. Yellowstone National Park stands as a testament to the power and beauty of our planet, a place where science and wonder converge.